The next store procedure is called stock percent change year period. And I definitely could have named this better, but for now, it is what it is. So this is one of the more important store procedures that I created, and the query for it takes several seconds, well, not even several seconds. It's going to take about anywhere between 30 seconds to about 2 minutes because there's a lot of calculations in the background. So just to give a quick overview of this store procedure. So in its simplest term, this store procedure is going to look at the average closing price compared to the next year, compared to a 5-year period, and compared to a 10-year period. And it's going to output the result as a percentage. And we're going to go over this query too, but I want to show you what it looks like first. So all these numbers, when you look at it this way, it's going to be confusing. And we use this output or data set in our Power BI report, and it becomes a lot more clear once we see that information. But let's take a look at the query itself, and it's a little bit long and complex, but it repeats the same pattern again for each year, for a 1-year period, 5-year period, and a 10-year period, but I will definitely explain it to you. So I'm going to try and explain this to the best of my abilities. So the first thing that we have here, we are going to select the distinct stock symbol, then the stock history.date. This is our overall stock history data. We're going to pull the date. We're going to format it as the year as well. And we are going to use the min format just to retrieve one date record. So as you can see here, we are going to have many dates within a year, but because of that, I just only want to select the minimum one and then output it as the year. Then we are going to use the average function and get the average for the stock symbol closing price. And it's only going to be for that specific year as well. Okay, so here is where it gets a little bit more complicated. So now we are going to use the lead window function, and we are going to get the average for the stock symbol closing price again, and it's going to be partitioned by the stock symbol and the year, or our date, which is formatted as the year. And because we are using 1 for the lead function, it is going to look at the next row, and this is going to be our next year average close, or basically a year over year period. Then the next column, which is called stock year change, is going to look at those two previous columns we created and subtract them both, and this is going to give us the dollar value in that. And then for the next column, we are going to calculate the percent change from those two columns we calculated earlier, where we had the average closing price and then the next year average closing price. And because some of the companies, when they first started trading in the market, started at $0, our closing price for some rows may have a value of 0. And so in order to avoid this, we are going to use the null if function. Using the null if function allows this whole store procedure to even work. And with that being said, since we looked at it at a year over year period or 1-year period, we are then in that next block of coding are going to take a look at it at a 5-year period and a 10-year period as well. So now that we've covered that, we could take a look at the rest of the query. We are only going to be using the stock history table, and then where the stock symbol history equal the stock symbol history. Those two are just basically going to equal each other. And then we're going to group it by the stock symbol and the date, which is going to be outputted as a year. And then it's going to be ordered by the stock symbol and our column called test date. And this is a output of our store procedure. All right, so to make this a little bit more clearer, I'll start with the first row that we have and walk you through the process. So we have our test date, and I name it test date because I was testing this store procedure out, or this query out, to see if I could get it to work, and it ended up working. So our test date is called the year, but in any other case, I would actually go back and change this to have it be named the year column. But for right now, it is what it is. So let's start with the first row. We have American Airlines, which is AAL, and you can see that their average closing price in the stock market for 2005 was $27.40. And in 2006, it was $41.78. So if you look at the first column, or excuse me, the third column, where it says stock average close, this is going to look at the closing price for that specific year. So American Airlines, it was $27.40 earlier, that I mentioned earlier, excuse me. And then in the next column, where we use our lead window function, it is going to retrieve the next row. So we are still looking at that first row, but in our next column, which is called next year average close, it is going to take the value that is in the second row, which is the average closing price for American Airlines in 2006, and output that as a value. So now that we have those two values on the same row, we could basically or simply subtract them from one another. And you can see when you do 41 minus 27, you get a increase of, or a difference of $14.38, with those numbers being exact. And then from those two columns earlier, the stock average close and the next year average close, we could get the percentage that they increased or decreased as well. So continually looking at the first row, you can see that American Airlines from 2005 to 2006 in a year-over-year period increased 52%. And we basically repeat this process for the 5 and 10 year period. I won't show the whole output because it could kind of get a little bit overwhelming. But if you look at the 5-year average close, you can see that it's going to pull the value in the first or the third column, excuse me, stock average close from the year of 2010, which is $8.14. And when not enough data is supplied, we get the value of null. So if I scroll over to the right a bit, you're going to see that we have several null values. And in row 6 is the year of 2010, and currently we are in 2020. If we look at the next row, which is row 7, and it's the year 2011, you can see that there are null values because we haven't started the 2021 year yet. So once we enter 2021 and we have data or information for 2021 for a particular stock symbol, this store procedure will update as well, and it will remove those null values. And like I mentioned before, looking at this data set like this can be very confusing to the eye. So we actually have a visualization in Power BI that makes this information a lot more clearer. And when we come across that information, or that visualization I should say, in Power BI, I will definitely let you know which one it is. And one more thing as well, the null values do not only appear in the 10-year period, it also could appear in the 5-year period as well, depending on when the company first publicly traded in the stock market. So the next store procedure I want to take a look at is called stocks not found in Fidelity. And just like its name says, coming from that Python script, it is only going to retrieve those companies or stock symbols that were not found on the Fidelity website. Once more, we are going to use a full outer join, and then we are going to specify where the stock sector stock symbol is null. And this is going to return all of our rows for where it is null in the stock sector table. That is another store procedure that we use in a Power BI report as well. The next store procedure, which is called yesterday's stock information, is basically we're looking at the same thing again as we did with several other store procedures, but we're looking at the data from yesterday. I don't really use this one in the Power BI report, but it's very helpful for whenever I need to take a look at a particular stock symbol and the current day has already passed. So I could quickly run this store procedure and I'll get yesterday information if the new data has not been updated yet, or if I want to look at yesterday information. The last store procedure we're going to take a look at is called stock performance search. And you can see that there are two parameters. You could use the stock finder, which is basically the stock symbol, and you could use the date you want to take a look at the information. So in our example, we have discover and the date of September 16th, in the year of 2020. And you can see the stock symbol, the name, the sector, the industry, where it opened, where it closed, and the latest date. And I named this column, I renamed it in the store procedure. And on a side note, one thing I want to talk about for several of these store procedures, and this one in particular, I could not figure out how to enter in multiple values for one parameter. I tried a lot of research in different methods I think might work, but unfortunately I couldn't get that one to work. Like, let's say for stock finder, if I wanted to look at Tesla and Nike stock for that day, I couldn't figure out a way to do it, so I just had to go with one value parameters. But other than that, that's basically it for the store procedures I've created. And again, mentioning that these store procedures I just created on my own. I came up with different ideas I wanted to look at. I tried to come up with some queries that may be challenging to build, but still obtainable to do. Basically with the overall goal in mind of trying to replicate a real life work scenario, but using stock information. So instead of writing long queries out each and every single time, we could basically use a store procedure and we'll be good.